हाँ, good afternoon. Just check, are you able to see screen? And my voice is also audible to you.
Yes, sir.
Uh, Work energy method. Again, one of the important chapter from the dynamics. Last important chapter, I will say. After this, only one chapter is remained, which is only theoretical chapter. There will be no any questions from last chapter. Before that, let us come to this work energy method. The terminologies are well known to you already. Is it correct? Work, maybe energy, power, kinetic energy, potential energy. Whether these terms are known to you? Hello? Hello? Just check. Am I audible?
Yes.
Syllabus, what you are observing on the screen. Quickly, I will read. Potential energy. Chapter is very simple. Don't worry. It is also simple one. We have studied D'Alembert's principle or kinematics. Not kinematics. What was the name of last chapter? Kinetics. Not kinematics. It was the kinetics of the particle where we have studied D'Alembert's principle. Okay, what is the statement or equation for D'Alembert's principle?
R minus M.
R minus M equal to 0. So whenever body is in motion, it is in dynamic equilibrium as well. So R minus M is equal to 0. Similarly, here also one equation we are going to see, only one equation. From that we are going to see certain terminologies. Okay. So color coding, already I have told, you should not think about color coding. All the syllabus is there in your right now exam. So earlier, last time, only black colored syllabus was there. It was skipped. So this time whole syllabus is there. Potential energy, kinetic energy of linear motion and a rotation. Principle of conservation of energy, work energy equation. Most important, work energy equation. Impulse momentum method. That also we are going to see. Important method. Impulse momentum method. Collision, impact. Types of collisions: impact, central, eccentric, direct, oblique, elastic, plastic. Coefficient of restitution. It is something like our coefficient of friction and loss of energy due to impact. So this terminology we are going to see. Okay, not necessary. If possible, you can log in from the mobile because some part theoretical part is also there. It is not possible to write each and everything. At the end, I am going to provide this PPT, solve the PPTs to you. Everything will be provided. Don't worry. Provided that it should not happen that you are not writing in the notebook. Huh? So I will provide all the things, right? You will get PDF of this, whatever we have solved as well, for your reference. That I will give at the end. Okay. Coming back to this work and energy. Very simple terminologies already you know, maybe in your physics. Okay. What is work? It is defined as मोबाईल चालू केला काय कोणी यू कॅन म्यूट करून ठेवा म्यूट फक्त स्क्रीनशॉट घ्या नसेल तर घेऊ सुद्धा नका तुमची मला काळजी आहे मी सगळं देणार आहे नंतर शेवटी इफ यू वॉन्ट यू कॅन टेक स्क्रीनशॉट अदरवाइज डोंट टेक स्क्रीनशॉट ऍज वेल ते सुद्धा कष्ट घेऊ नका देतो सगळं तर अभ्यास मात्र तुमची तुम्ही करायचं वर्क काय झालं ओंगर माझ्या काय वेगळं आहे हसायला लागले सगळे बघून का शेवटचं लेक्चर आहे म्हणून हसायला लागले नथिंग नो एनिथिंग न्यू काय म्हणताय काय सुद्धा नाही ना काय असलं तरी मला काय फरक पडत नाही ओके work it is defined as the product of force and we know work done is equal to F into S. It is as simple as this. So work done. Online students, are you with me?
Yes, sir.
Yes, sir.
Be with me. Otherwise, it is very difficult. We know work done is equal to force into displacement, and whether work is scalar quantity or vector quantity. Work done. कसं असते work done or work scalar or vector? Scalar. Sure. कशाचा प्रोडक्ट आहे वर्क डन म्हणजे काय सांगितलं मी फोर्स इंटू फोर्स
Displacement.
कशी क्वांटिटी आहे फॉरगेट अबाउट फोर डिस्प्लेसमेंट वर्क डन कसं असू शकतो कॅन वी से वर्क डन इज अ स्केलर असं ऐकलंच नाही का तुम्ही ओके लेटेड यू विल सी first thing you should remember work done is equal to or if there is a one body and a certain force is applied on that body and that body gets displaced from one place to other place then work done by that force on the body is given by force into displacement हे तर माहिती okay so we will see one by same is here now so one of the figure is shown here in which a body is at A and different forces are applied right from P1 where is P2 here P2 P3 P4 different forces are applied at point A and they just it is displaced from A to B okay and here that work done is given because according to definition itself it is defined as the product of force into distance covered or moved or we can say displacement so P1 as it is a horizontal force P1 into S. This S is a displacement or distance covered by that. Okay. So work done by P1 force, P1 into S. Next, P2. Where is P2 here? So though the force is in this direction, left hand side, towards left hand side, body is going to move from A to B. So P2 is equal to into S. So why it is came displaced from A to B, force is in this direction. Negative. So whatever work of P2 force, P body is moved from A to B, P3 force distance covered or displacement. Which component? Its component, horizontal component. So what will be that? P3 cos theta. The value of theta will be how much this angle will be 90 and cos 90 is how much cos 90 0 means work done by this P3 force will be how much 0 why because once we are going to take its horizontal component P3 it will be P3 cos theta and that force we are applying perpendicular to the here one multiple choice question may be possible if body is displaced from A to B but force is perpendicular or we can say if force is perpendicular and displacement certain displacement will be there then work done by that force is 0 त्या force ने work done केलेलं आहे 0 असतं okay so this thing you might be knowing when to consider work done positive and when to consider work done is negative the simple rule you might be knowing maybe in your 11th or 12th or somewhere if movement or displacement of body will take place in the direction of applied force then we are calling it as work done as positive correct and if movement or displacement of body will take place opposite to the we can say force applied then it will be a negative for example in this case where the force is applied and where is the body is going force कुणीकडे चाललाय लेफ्ट कडे बॉडी कुणीकडे चालली राईट कडे दॅट्स वाय वर्क डन बाय दिस P2 force is negative हे माहिती आहे का तुम्हाला If it is known, you should say yes. If not, I have to explain more. Two things we have seen. If displacement will be there according to direction of force, positive force into displacement. If force is perpendicular, work done is zero. Second thing. And if force is displacement is exactly opposite to the displacement, then it is negative. Means when it will be positive, when it will be negative, and when it will be zero. So three cases you have to see here. For multiple choice question, it may be asked three cases. When it will be work done is positive, when it will be negative, when it will be positive. Likewise, you have to remember. If displacement will take place uh, along the direction of applied force, work done is positive. If force is perpendicular to the displacement, work done is zero. And if force maybe there 180-degree angle or exactly opposite, force applied, displacement is happening exactly opposite to the force applied, work done is negative. So these three cases you should remember here. Okay. Further, from the definition of work here we have seen it is nothing but product of force and distance covered, that is displacement we can say. By the so here from the definition of work it is obvious that unit of work we know now, we should not go for unit of force is what, Newton, and unit of displacement is what, meter. So this Newton meter is known as, what is that, 1 Newton meter, 1 joule, and 1 joule per second is known as amount of work done per minute. What is that? Joule per second, watt. Unit of power, that is watt. No, are you knowing this? Joule per second, we will see further, don't worry. So 1 joule of work, very basic. This 1 joule of work done is amount of work done by 1 Newton force, 1 Newton and 1 meter, when particle is going to move from 1 meter. Means one in we can say simplest language we can say here it is written 1 Newton meter is equal to 1 joule. It is as simple as this. As simple as this. Once we are going to apply 1 Newton force and the body is going to displace from 1 meter distance, it is 1 joule. Simple. Okay, are you with me online? Many more are there today.
Yes, sir.
40. Okay. Energy next. What is energy? At engineering level, these definitions are very, you can say, basics. You are already knowing these terms. What is energy? Energy is nothing but capacity to do work. माहिती आहे ना तुम्हाला? Have you came across these terms? Okay. There are many forms of energy like heat energy, mechanical energy, electrical energy, chemical energy. Okay. In engineering mechanics, in our subject, we are interested in mechanical energy. We are interested in mechanical energy. This energy may be classified into two types. That also you might be knowing. Potential energy and kinetic energy. What is potential energy? What is potential energy and what is kinetic energy? Energy possessed by the body due to its position is called as, example. For example, hmm, due to position, dam. Here's the example. हॅलो, येतोय ना? आपण हॅलो, जस्ट चेक. मानसी, roll number 30. You are saying no, voice is not coming. Is it audible now? Is it?
Yes,
Okay. Okay, no issue. Maybe there is सगळे सांगायला लागले बघा. नो इश्यू, आय गॉट युअर मेसेज. भावना पोहोचले, मेसेज टाकू नका. मी बंद करतो चॅटिंग तुमचं. ओके. Kinetic energy. We were up to kinetic energy. Okay, kinetic energy is the capacity to do work due to what? Due to its motion. So here we can say energy possessed by the body due to its motion is nothing but kinetic energy. Okay. And this formula also well known to us. Kinetic energy is equal to 1/2 mv square. And if you will convert this into here, so what is that? Since we can say W is equal to mg, so it will be something like this. Okay, so this is related to energy. What is energy and what are the different types of energy? So that we already know. Okay, further, power. What is power? It is defined as time rate of doing work. Means work, time rate of doing work. It is nothing but power. Unit of power is watt. Okay, and defined as 1 joule of work done. Double it should not. Work done. 1 joule of work done in 1 second, or simply we can say 1 watt is equal to 1 joule per second. Is it correct? असंच आहे का हे? असंच आहे. 1 watt is equal to 1 joule per second. Okay, in practice, kilowatt. Okay, commonly used is we are not going to consider power. We are going to relate only work and energy. Horsepower, it may be known to you now. Horsepower is a unit used in MKS and FKS. FKS means what? Huh? Okay, foot pound second system. Okay, horse 1 HP. 1 HP. Okay, I think it is 746, no? Or 8. 6, I think. Exactly, it may be 745.8. Okay, don't worry. It is not required. So here we have to remember only. Here we have to remember only what is power. What is power only. Next. Coming back to core syllabus of this chapter. So earlier terms, already you know this. What is power? What is work? What is energy? What are different types and how work is done? So this one is also important. 3 cases. When we have to say work is done. कधी म्हणायचं एखाद्या फोर्सने वर्क डन केलं असं कधी म्हणणार आपण? When we have to say work is done, there should be a displacement due to that force. Okay. Now this also you might be knowing. Suppose there is one object. There is one object having maybe suppose 1 ton weight. Maybe I will write 1 ton, and maybe you have applied 1000 Newton force. Maybe something, but body is not displaced at all. It is remained at one place or that place only. Can we say work done? Something work done by this force? No, because unless and until there is no displacement, we cannot call as the work is done. It is as simple as this. Because work done itself is a product of force applied and distance covered by the body. Unless and until there is no displacement, there is no work done. Okay, that thing we have seen: energy, power. Now this equation, most important, work energy equation. So as like our D'Alembert's principle, here there is one more equation we are going to see, that is called as work energy equation. So what it tells, because this total chapter is going to be on this equation. पूर्ण chapter एका equation वरच चालतोय. Whole chapter. That equation is nothing but work energy equation. What is that? It states that actually there is lengthy derivation, etc. We are not going to enter into derivation, etc. Work done by a system of forces. So there is one body. You can see the figure. There is one body which is initially at point A, after application of number of forces, maybe F2, F3, this F4, F4, or F4, maybe F1, F2, F3, F4. That body is going to displaced from point A to B. Okay, due to application of these many number of forces. Then that equation, what it says, work done by system of forces acting on the body during a displacement is equal to the change in kinetic energy of the body during the same displacement. So whatever change in displacement is going to happen, so that change in displacement we are going to take into account, and that change in displacement, change in kinetic energy, sorry, not displacement, change in kinetic energy, that we are going to call it as a work done by system of forces. Whatever number of forces are going to apply on the body, that we are going to call it as work done. And that change in kinetic energy, how we are going to give here, if this equation here, if I will write work done by, work done, I will write in short WD, work done by all the forces, change in kinetic energy. So final kinetic energy minus initial you have to take, or initial minus final? Final minus initial. So final velocity suppose V and initial is U. Is it correct? No. So we can write same, and work done formula also we know what is that, F into S. Or here number of forces are there, number of forces. The resultant of that we have to take. So instead of I will say F, I will take R, maybe something like this. R into S equal to 1/2 M will be common, V square minus U square. Like this also we can write, or this M, we are not using mass anywhere. We are going to use this mass in terms of weight. How we have to use this? Use then R into S equal to 1/2 into M. How we can write in terms of W by G into V square minus U square. This will be the equation. Means what the way we have seen. What the way we have seen equation for D'Alembert's principle. What is the equation for D'Alembert's principle? Simply R minus M equal to 0. Here, this is the equation is called as work energy equation. R into S equal to 1/2 W by G V square minus U square. Now question may come. So what is the difference between this work energy equation and D'Alembert's principle? So there is a specific, we can say, importance of both. So here as a star mark I will say, what is that? In case of whenever we are required to find, in case of D'Alembert's principle, this D'Alembert's principle extensively used for whenever we are necessary to find acceleration, because in that formula whether acceleration is there equal to 0, याच्यामध्ये acceleration आहे का हो? R minus ma equal to 0, because this whenever we need acceleration of the body, we are going for D'Alembert's principle extensively, otherwise both are same. On the other hand, this work energy equation, okay, I will write here work energy equation. Okay, whenever we need two things, one is displacement, yes, because force is already applied to the body. Whenever we need to find displacement and velocity, then in that case we are going for work energy equation. Means by the problem statement also you can find, from the problem statement also you can understand, okay, whether you have to apply work energy equation or whether you have to apply D'Alembert's principle. So whenever we don't need any kind of acceleration of the body, then we are going for work energy equation. Okay, आलं का लक्षात? थोडंस लिहत चला, तुम्हाला झोप लागायला लागलेली आहे. पेन घ्या हातामध्ये. So you can write D'Alembert's principle. D'Alembert's principle. Why for D'Alembert's principle is used? कशासाठी वापरलं जातं डिअलेम्बर्ट प्रिन्सिपल? When what we need, in that case we are हा काय माहिती पाहिजे असते त्यावेळी आपण डिअलेम्बर्ट प्रिन्सिपल वापरतो. Acceleration. When it is necessary to find acceleration, we are going for D'Alembert's principle. And when we are going for work energy equation, काय काढायचं असतं त्यावेळी आपण वर्क एनर्जी इक्वेशनला जातो. तर लिहिलंय मी ब्रॅकेट मध्ये. डिस्प्लेसमेंट, वेलोसिटी, इट मे बी फायनल और इनिशियल. इट मे बी फायनल और इनिशियल. म्हणजे फायनल असेल किंवा इनिशियल असेल. Online students, are you with me?
Yes, sir.
What is the difference then when we have to go for D'Alembert's principle and when we have to go for D'Alembert principle and when we have to go for work energy equation, simple one, nothing else. So whenever we need, or if at all we are going to concern with acceleration, then we have to go D'Alembert principle. If not, work energy equation. Whenever we want to go for displacement and velocity, it may be final or initial. Okay, shall we go next? जाऊया पुढं. Shall we go next? Hello, online students. Shall we go next?
Yes, sir.
Yes, sir.
And you writing, no? When you are going to come college? Online students, are you doing study? I hope. We are in last, we can say, phase of this subject. Okay. Next. Problems. Our favorite problems. Because there is nothing apart from problems. In this subject, there is nothing apart from problem. I don't know whether you like problematic subject or not, because problem statement. Shall I read loudly? You can give just problem number. Actually, I have not given. You can give problem number afterwards. You can write, because problem statements are bigger one. It may take more time to write, or if you having practice to write, you can. A car moving on a straight level road skidded for a total distance of 60 meters after the brakes were applied. Determine the speed of the car just before the brakes were applied. If the coefficient of friction between the car tires and the road is 0.4, take G is equal to 9.804 meter per second square. So what is problem statement? What is problem statement? There is one road, straight level road, okay, on which a car is moving, and whenever that car was moving, brakes were applied. After application of brake, car skidded for 60 meter distance, okay, and we are necessary to find speed of the car. इथे स्पीड पाहिजे बघा, किंवा व्हेलॉसिटी म्हणू आपण. स्पीड और व्हेलॉसिटी जस्ट बिफोर द, काय झालं काय, velocity, okay, velocity just before the brakes were applied, and coefficient of friction. Let us see what it is given. ओंकार सांगू शकता का तुम्ही काय दिलंय? ओंकार तुमचंच नाव ओंकार आहे ना? सांग. आय एम कन्फ्युज व्हॉट इज युअर. सांगा की मोठ्यानं. हा सांगा फक्त. तुम्हाला काय समजलं सांगा याच्यावरून, बाकीचे लिहिते तोपर्यंत. व्हेरी गुड. हा 60 मीटर. 60 मीटर गेल्यावर ब्रेक मारला असं नाही, उलट सांगायला लागला. सांगा बरं फास्ट. हा ब्रेक मारल्यानंतर 60 मीटर पुढे गेले, मग ते काय कारण म्हणायचं? 60 मीटरला काय येते? व्हॉट इज दॅट? 60 मीटर. हा ओके, फॉरगेट अबाउट इट. कार इज गोइंग ऑन द रोड. कार चाललेली आहे, ब्रेक लावलेले आहेत. पहिल्यांदा इनिशियल व्हेलॉसिटी आणि फायनल व्हेलॉसिटी काय असेल त्याची? फायनल तर 0 असेल, कारण कार ब्रेक लावल्यावर थांबणार आहे जर ब्रेक चांगले असतील तर गाडीचे. बरोबर आहे, म्हणजे फायनल तर 0 असणार आहे. ठीक आहे. आणि व्हॉट अबाउट दॅट? आणि व्हॉट वी आर नेसेसरी टू फाइंड? आपल्याला फाइंड आउट काय करायचं आहे? स्पीड ऑफ कार. आय विल राईट हिअर. That we are necessary to find. Anything else is given? Mu is given. Mu, how much? 0.4. Okay. And G, anything else is given? V, U. Okay. Yes is also given. How much? 60 meter. S is also given 60 meter. Okay. And we are necessary to find. We want to find what? U equal to 0. Try to understand. It is very simple. अतिशय सोपा आहे. झालं? प्रॉब्लेम स्टेटमेंट इकडे बघा. ऑनलाइन स्टुडंट्स, आर यू विथ मी?
Yes, sir.
Yes, sir.
Okay, very good. What is there? There is one straight road. काय लागलंय? Just check. There is a straight road. And from this road, a car is moving. कार चालली म्हणजे एक्झॅक्ट कारच काढायला पाहिजे असं काय नाही. मी एक ब्लॉक काढतो असं आणि इथं म्हणतो कार चालली अशी काहीतरी. ठीक आहे. कार इज मुव्हिंग. ओके. देर मे बी सर्टन वेट ऑफ दॅट कार. त्या कारचं काहीतरी वेट असेल, येते लक्षात. सो इट मे बी अप्लाइड मे बी इन दिस वे. त्या कारचं काहीतरी वेट W असेल इथं. ठीक आहे. And it is moving at here, suppose that V is going to become 0 and that car is moving with velocity U initially, that we want to find. Okay, that V is going to become 0, this W, and mu is also given for here. How much it is given? Mu 0.4. 0.4. Then there may be a reaction from the road to the tires. At the end of tire there will be certain reaction. आपल्याला माहिती आहे. In case of friction, what is that formula? From friction, we know formula for F. What was that? F is equal to mu R. R is what? Reaction. How we are finding that reaction? Reaction कशी find out करतो आपण? टायर च्याला किती reaction असेल? This reaction W, and this will be R. This R is equal to W. Can I say R is equal to W? Okay, so we can write in this way, mu into mu W. If at all I will write mu W in this way. हे असं पण लिहू शकतो बघा. Because R and this, it is equal. Okay. As I told right now, what we are necessary to find? Velocity. So just before we have discussed this, so whether there is certain constraint of here acceleration, कुठे विचारलंय का acceleration? जर विचारलं असतं तर आपल्याला D'Alembert कडे जावं लागलं असतं, हे लक्षात ठेवा. When to use D'Alembert principle and when to use energy equation. Unless and until we don't need acceleration, we should not go to D'Alembert. Because in D'Alembert principle, acceleration is there. And here, two things, either velocity, it may be final, initial, and displacement. Because in that formula, these three terms are there, this one. Displacement, final velocity, and initial velocity. Okay, and what is R in this equation? What is R? Huh? What is R in this equation? Huh? Force, only force or resultant force? That's why resultant force. Work done, simple formula, F into S. But here resultant, if number of forces are acting, the number of forces are F1, F2, F3, F4. So that is resultant force acting on the body, displacement, final velocity and initial velocity. Let us apply this and we will see what is happening. Okay, are you with me? Apply. Shall I write in short work energy equation? Work energy equation. So what will be that? F into S equal to 1/2 into W divided by G. W divided by G into bracket. What is that? V square minus U square. Okay. So here are you with me? लक्षात आहे काय चाललंय कळतंय का हे?
Yes, sir.
Now, one more thing just here we have to consider. So which things we are knowing now? Whether we are knowing force, whether we are knowing yes, W, no, G, yes, V, yes, U we want to calculate, no? Okay. So what will happen here? One more thing here important, most important thing. Whenever we are doing work against the any force, एखाद्या फोर्सच्या अगेन्स्ट किंवा एखाद्या बॉडीवर आपण काय म्हणूया आपण अगेन्स्ट द फोर्स और अगेन्स्ट द डिस्प्लेसमेंट ज्यावेळी फोर्स लावतो त्यावेळी ते वर्क डन हे निगेटिव्ह असते. काय म्हटलं मी? अगेन्स्ट द डिस्प्लेसमेंट म्हणजे इथं जे आता वर्क डन होणार आहे आफ्टर ऍप्लिकेशन ऑफ ब्रेक, रिटार्डेशन विल स्टार्ट or it is the work done against the displacement. That work done is also 0. You can write somewhere. Work done against the displacement or against the force is 0. Force म्हणता येईल का? नाही. Work done against कशाच्या म्हणावं लागेल? इथं वर्क डन असतं ते 0 असतं because whatever movement is going to happen, so that will be 0. This work done is also 0. इथं सुद्धा आपल्याला वर्क डन आहे बिकॉज अगेन्स्ट द डिस्प्लेसमेंट और अगेन्स्ट द मोशन म्हणूया आपण मोशनच्या अगेन्स्ट जे वर्क डन असते ते वर्क डन अगेन्स्ट मोशन म्हणतो मी सिंपल. इज कसलं म्हटलं मी हो? इज negative. That's why here I have to give negative. Now can we put this F in terms of the here? I will give equation number A to this. From A I will write. From equation A, what will be the value of F minus, just check, UW equal to, sorry, into S. Sorry. Into what is that? W is how much? W, or meanwhile we will do as it is 1/2 into W upon G into V square minus U square. So minus what is mu? 0.4 into W, because W is going to cancel, huh? Yes, value of S is known to you. Into this 60 equal to 1/2 into this W, value of G is 9.81. काय म्हणतात? 80 घ्यायचे. ओके. 9.80. 9.80 into v square is 0, no? Minus u square. From this, calculate u. You do the calculation and you tell me what is value. Go for simplification. Online students, you also go for the calculation and tell me. This w is going to cancel. Huh? This w here and this is going to cancel. So just check how much it is now. Calculate this. So what you have to do? 0.4. Forget about sign now. This minus u square is there here. Huh? And this minus, it is going to become again plus. Both sides will become plus. So simply, you have to take 0.4 into 60 into 2 into 9.80, a square root of that. What is that? U. $21. Point. Any other? 21.68 unit second square. Are you with me?
Yes, sir.
Hello. Are you getting very simple? We have applied work energy equation. What is work energy equation? Work done by the force is equal to change in kinetic energy. F into S is equal to 1/2 into W divided by G into V square upon V square minus U square. So why we have taken work done is here 0. Sorry, not 0, minus. Why we have taken minus? Work done is minus. Minus का घेतला आपण work done? Motion. Work done against the motion will be negative. That's why we have taken negative. समजलं? Same here, same. When we have to use D'Alembert principle and when we have to use work energy equation, इथे acceleration काय संबंध आला गाव आपल्याला? Whether we are concerned with acceleration, if you see problems related to D'Alembert's principle, you will come to know that in many problems it was asked to find acceleration. So this is the thumb rule. You can remember which equation we can use or which equation we can apply to solve the problems or to analyze the problem. Okay, shall we go next? Zala, next. Online students, shall we go next?
Yes, sir.
Next. काय म्हणताय? काय म्हणताय साक्षी? Okay, next. Problem number 2. Read the problem and try to analyze. Body or block. Just check, are you able to solve? First, think for a while and just check. Can we solve this? Can someone read from online so that all will wake up? Maybe Sakshi Kadam Patel, 11. Kadam Patel.
Yes, sir.
Dheeraj, how will you read this problem statement loudly for all of us?
Yes.
Huh.
A body weighing 300 Newton is pushed up a 30-degree plane by a 400 Newton force acting parallel to the plane. If the initial velocity of the body is 1.5 meter per second and coefficient of it becomes to 0.2, velocity body will have a moving meter.
Very good. Thank you. A body weighing 300 Newton is pushed up a 30-degree plane by a 400 Newton force acting parallel to the plane. If the initial velocity of body is 1.5 meter per second and coefficient of kinetic friction is 0.2, what velocity body will have after moving 6 meter? Very simple. All things are given. Everything is given. So weight of the body is given how much? I will give given things, you can try. 300 Newton, then force is applied, okay. Then what it is given? With initial velocity, it is told that with initial velocity. So U equal to, how much it is? 1.5 meter per second. Okay. Coefficient of kinetic friction. Why it is called kinetic friction? Because body is in motion. That's why that word came. So mu 0.2. And to find V equal to how much? So velocity is asked. As like we discussed, if we need acceleration, go to D'Alembert. If we need any velocity displacement, go to work energy. Let us see. Is it possible for you to solve this? So it is need to solve or it is required to go for FBD. FBD of block. FBD of block. I will draw here. So there is an inclined plane. Maybe it is something like this, on which there is a block or body. Maybe something like this. Okay. Then this weight is going to have in which direction? Downward direction. In downward direction, no? How much it is? 300 no? Newton. So once निहाल काय झालं सोडवा. There will be we can say reaction. I will give it as R. Okay, and that reaction, how much it will make angle with vertical? In equilibrium we have seen, if the plane will make certain angle with horizontal, then this reaction on that inclined plane will make angle with whom? या रिएक्शन ने एन म्हणले किंवा आर म्हणूया आपण, नो इश्यू. कुणाशी केलेला ते सेम अँगल असतो की जेवढा प्लेन हॉरिझॉन्टल शी केलेला अँगल आणि रिएक्शनने व्हर्टिकलशी केलेला अँगल कसा असतो म्हणलो होतो आपण, सेम. इट विल बी 30 डिग्री अगेन. Newton force is applied in this direction. Okay, 400 Newton force is applied. Okay, so what will be the direction of frictional force? Frictional force कोणीकडे असतो? Opposite to the motion. Now in which direction this block is going to move? Upward or downward? कोणीकडे जाईल ब्लॉक? ब्लॉकचं वजन आहे 300 न्यूटन आणि त्याला ढकललेला आहे 400. पुशड म्हणजे ढकललाय 400 न्यूटन. म्हणजे वरती जाईल का खालती येईल? Obviously it is going to go for in upward direction. So frictional force will be in downward direction. So in this way. Yep. Okay. Are you with me? And how we are giving frictional force? Yep. Yep कसं देतो? What is formula for frictional force? Yep. Mu into R. What is R in this formula? Normal reaction or reaction? How to find that reaction? For that, what we have to do? This 300 Newton force we have to resolve first. त्याला resolve केला पाहिजे. बरोबर आहे? Its component one will be in this direction and one will be in this direction. इकडे असेल. बरोबर आहे? मग मला कोण सांगते आता X component of this? कुठं घेऊया? मी इथं घेतो आता. थोडंच लक्ष द्या. इकडे घेतोय मी. इकडून असा. X component of this 300 Newton means along this angle कोणा बरोबर केलाय? त्या नॉर्मल रिएक्शन ला केलाय. मग किती गेलो? 300 साइन और कॉस? हॉरिझॉन्टलचं नाही चाललं, माझा ही चाललाय कंपोनंट. along this cos 30. cos 30. Okay, and one will be या वेटच्या इकडे जाईल in this direction. Okay, and this component इकडे घेतो तुमच्या लक्षात येण्यासाठी. हा, आणि हा वेट आहे बरं 400 आणि हे इथे किती असेल? 300 sin 30. From this, now can we find value of normal reaction R? R ची व्हॅल्यू किती येलो? R या काय तर वरती चालली इकडं आणि हा 300 cos 30 खालती चाललेला आहे वेट कंपोनंट. हाउ टू फाइंड देन R? R कसं फाइंड आउट करणार? येस, R वरती चाललाय म्हणून पॉझिटिव्ह मायनस हा 300 cos 30. This 300 cos 30 is going downward, that's why it is negative, equal to 0. From this, R is equal to 250 80. Okay. From that, can we find F? आता ह्याच्यावर आपण F फाइंड आउट करू शकतो का? F चा काय फॉर्म्युला आपला? F is equal to mu into R. mu माहिती आहे का आपल्याला? Yes, we know mu. So mu into R, that is equal to, what is mu? 0.4 into sorry 0.2. okay, 0.2 259 point किती 80 ना, equal to 51.96 युनिट काय असेल व्हायचं? न्यूटन. आता जाऊया, चला कुठं जाऊया? वर्क एनर्जी इक्वेशन कडे जाऊया. Is it possible to apply now work energy equation? That should be known to us. F into S 1/2